Yeah, good day to you all. I hope you're ready for another class in physics. Today we are treating the topic machines. Yes, we are treating machines. Now, literally, in one way or the other, you might have come across different types of machine. But now, how it works and some little calculations under it is what we'll be treating today. Now, looking at the board, machine is a device that allows a force. That force simply means your own efforts applied at one point to overcome resistant force, which is the load, at another point. Now let's take for instance, you saw a screw on the wall. You want to remove the screw. You can't just place your hand on the screw and remove the screw. No. You have to apply a force. That force you are applying using a screwdriver to remove the end of the screw is your what? Your effort. Now, as the screw is about coming out of the wall, it has to overcome resistant force from the wall that is actually holding it back. And that resistant force is the what? Is the load. So for you to successfully remove that screw, you must apply a force. Your own force is your what? Your effort. The resistant force that the screw is trying to resist, that okay, it wants to come out, is the what? Is the load. Now, for your calculation on machines, you have to be familiar with two different words, which are the mechanical advantage and velocity ratio. Now, the mechanical advantage is just the ratio of the load to effort. The load to effort. You can as well use the output force over input force. Output force over input force. So depending on what the question says, will enable you to know, okay, am I using load over effort? Am I using the output force over input force as my mechanical advantage? Mechanical advantage doesn't have any units because the load is measured in newtons, the effort is measured in newtons, and they will both cut out. Now, velocity ratio. This is the distance moved by the effort over distance moved by the load. The distance moved by the effort over distance moved by the load. Meanwhile, the formula for this velocity ratio varies with different machines. It depends on the geometry of the machines. So as time goes on, we'll be talking about the different velocity ratio we have based on the different types of machine we have. So now, efficiency, measured in percentage, can be calculated by using this formula: work done by the machine over the work put into the machine. There are different ways in which you calculate your efficiency, but all this thing depends on the type or the parameters given to you in the question. You can as well use your mechanical advantage over velocity ratio times 100 to calculate your efficiency. Now, let's look at this question. A machine whose efficiency is 75% is used to lift a load of 100 Newton. Calculate the effort put into the machine if the velocity ratio is 4. Now, first of all, we need to write out the parameters given to us in the question, as this will enable us to know what we are actually calculating. So now we were given the efficiency. Our efficiency equals to 75%. Good. The load is what? Our load is 100 Newton. We were also given the velocity ratio as 4. Now, if you can recall, efficiency equals to what? Efficiency equals to mechanical advantage over the velocity ratio times 100. Now, what is our efficiency given to us in the question? 75. We don't know our mechanical advantage times 100 over velocity ratio is 4. Cross multiply, we have MA equals 75 times 4 will give us 300 over 100. So our mechanical advantage is 3. Remember I said it doesn't have a unit. So your mechanical advantage is 3 here. So now, let's go back to our formula. Mechanical advantage equals to what? Mechanical advantage equals load over effort. We were given the load as 100 Newton. Remember, our mechanical advantage is 3. We were given the load as 100 and we are looking for effort. So here, effort will be equals to 100 over 3. And here we have what? 33.3 Newton. Because our load is in what? Is in Newton. This is just like a preamble. I just want you to be familiar with the basics, which is the mechanical advantage as well as the velocity ratio. So in any question you were given and you were given your mechanical advantage as well as velocity ratio, and you are told to calculate your efficiency, it's a straightforward question. But look at this one, there is a twist, because you were not given the mechanical advantage, you were only given the load. But from here, mechanical advantage has been derived, and using mechanical advantage as load over effort, we can actually calculate for our efforts. Do you understand that?